Hi all, this is Shweta Reddy, working as Assistant Professor in the Department of Electronics and Communication Engineering from R.M.K College of Engineering and Technology. So today in this video of transmission lines and waveguides, we have already seen the applications of Maxwell's equation to rectangular waveguides. So we are going to just continue from that video. So if you didn't see that video, please do visit that and come back to this video so that you will be understanding it better. So in the previous video itself, we have seen these wave equations and that is del square E del square H, and I have also explained that gamma square value is this, and after substituting the value of gamma square, you will be getting the del square E and del square H like this, and after expanding the above equations in X, Y and Z coordinates, you will be getting the equation as like this, and I have marked this equation as equation number 7. I have already explained this in the previous video. So in this video, I'm going to assume that Hy is equal to Hy naught e power minus gamma z. So partially differentiating the above equation with respect to z, that is Hy will become dou Hy by dou z, and Hy naught is nothing but constant, so I'm writing as it is. And this e power minus gamma z, with partially differentiating with respect to z, I'll be getting minus gamma e power minus gamma z. So rearranging this equation, I'll be getting it as minus gamma Hy naught e power minus gamma z. So instead of this Hy naught e power minus gamma z, I have assumed it as Hy. So I'm going to just replace it by Hy. So I'll be getting minus gamma Hy. So this is what the equation, that is dou Hy by dou z is nothing but minus gamma Hy. I'm going to take this equation as equation number 8. So in the previous slide, I have got dou Hy by dou z is equal to minus gamma Hy. So similarly, wherever I have y, if I replace it by x, I'll be getting it as dou Hx by dou z is equal to minus gamma Hx. So we have completed for H. Now we are going to do the similar step for E. So I'm going to assume Ey is equal to Ey naught e power minus gamma z. So similarly, if I partially differentiate with respect to z, Ey will become dou Ey by dou z, and Ey naught is constant, it will be remaining as it is, and e power minus gamma z will become minus gamma e power minus gamma z. So rearranging the equation, I'll be getting it as minus gamma Ey naught e power minus gamma z. So we have assumed that Ey naught e power minus gamma z as Ey. So I am going to replace it by Ey. So dou Ey by dou z is equal to minus gamma Ey. Now I am going to similarly write it for x. So wherever you have y, just replace it by x. So dou Ex by dou z is equal to minus gamma Ex. So I am going to mark these equations as 10 and 11. Now I have got this 8, 9, 10 and 11. So if I just substitute this 8th and 9th equation in the 5th equation, I'll be getting these 3 equations. So just the substitution I have done here. So now similarly, I'm going to substitute this 10 and 11 in the 6th equation. So I'll be getting these 3 equations. That's the substitution of 10th and 11th equation in the 6th equation. Now this third equation can be written in the z direction. That is, without z we have written the third equation. Now with in z direction, if I write dou square Hz by dou x square plus dou square Hz by dou y square plus dou square Hz by dou z square is equal to minus omega square mu epsilon Hz. And similarly for E, dou square Ez by dou x square plus dou square Ez by dou y square plus dou square Ez by dou z square is equal to minus omega square mu epsilon Ez. So as I said earlier, instead of this dou square Hz by dou z square, I'm just replacing it as minus gamma Hz. And similarly, so I'll be rearranging the equation and writing like this. And I have I have got the 13th equation. From the 13th equation, I'm going to take this Ey alone, which is in the right hand side, and the remaining terms I'm going to bring it to the other side. And I'm going to take the 15th equation, and in the 15th equation I'm going to take Hx alone, which is in the right hand side. I'm going to take this Hs alone in one side, and the remaining terms I'm going to write it in the other side. So I have got those equations as 20 and 21. Now I'm going to substitute this 21 in 20th equation. So I'll be getting the equation like this, and after some simplification, I'll be getting like this, and after that I'm going to bring this j omega j omega epsilon to the left hand side. So I'll be getting minus j omega epsilon Ey, and the remaining terms I have written as it is. And after that I'm going to bring this Ey term, which has gamma square by j omega mu to the left hand side. And after that what I'm going to do here is I'm going to take LCM. After taking LCM, I'm going to take this Ey term alone as common, and the right hand side will be following as it is. And after that we all know that instead of this omega square mu epsilon plus gamma square, I'm going to I can replace it as h square. So Ey of h square, and this term to the right hand side, I'm going to bring it to the right hand side, and the remaining terms I'm going to write as it is. And after that at last I'm going to take this h square also to the right hand side. So from this I can write the Ey term alone. So this is how I have got the Ey. Now what I'm going to do here is we have first substituted 21 in 20. Now what I'm going to do here is I'm going to substitute 20 in 21. So now we can obtain the other hx. We are going to obtain hx. So if I substitute this, I'll be getting like this, and after simplification I can write the equation like this. So after that the same procedure will be repeating, that is this j omega mu I'm going to take to the left hand side, and after that this term, that is which has hx term, I'm going to take to the left hand side, and after that I am going to take LCM. And after that what I have done is I'm going to take this hx term common, and instead of this omega square epsilon mu plus gamma square, I'm going to replace it as hx square, and after that hx square also I'm going to take to the right hand side, and I have obtained the hx equation like this. Now we have obtained hx and Ey. Next what we are going to do here is I'm going to take the 12th equation. From the 12th equation there is an ex term in the right hand side. So I'm going to write this ex term alone one side, and other terms I'm going to bring it to the other side. So similarly I'm going to take the 16th equation. In the 16th equation I have hy in the right hand side. So I'm going to take this hy alone in one side, and the other terms I'm going to write it in the other side and obtain it as 24 and 25th equation. So similarly what I'm going to do here is I'm going to first substitute 25 in 24. I'll be getting the equation like this. The same procedure I'm going to repeat, that is I'm going to take this j omega epsilon to the left hand side, and after that the term which has ex I'm going to take it to the left hand side, and after that I have taken LCM, and after that I am going to take this ex term alone common, and after that what I'm going to do here is I can replace it as h square, and after that this h square also can be brought to the right hand side. Now I have got the equation for ex. First what I did, I have substituted 25 in 24. Now I'm going to substitute 24 in 25. So I'll be getting that hy term. So hy term is equal to, if I substitute like this, I'll be getting the equation, and after simplification the equation will be like this. And similarly I'm going to take this j omega mu to the left hand side, and after that what I'm going to do here is similarly, I'm going to take LCM, and after taking LCM, I have taken this hy term common, and after that, I am going to replace this gamma square, that is minus omega square mu epsilon minus gamma square as minus h square minus minus. This minus I have taken common, and after that, I have replaced by h square, and repeating the same steps, and after that, finally, taking this h square to the right hand side, I'll be getting the hy equation also. So this is how I got ex, ey, hx and hy equations. So this is what about applications of Maxwell's equation to the rectangular waveguides. Thank you all.